We are on the section 11.5, page 52. Solve systems of nonlinear equations. Okay, so far we have been learning what? Conic system, right? So that's the first thing we are learning in this class. So for conic system, which includes what? Parabolas, circles, ellipses, and hyperbolas, right? This is the first thing we are learning. And second thing was what? Log. Remember that? So within the conic system, one more thing we are going to learn is what? Solving system of nonlinear equations. Okay, so we did what? Solving system of linear equations. We did this in your 152B class, right? What are those? Those would be linear equations. It's like this. Something like that, right? Those are linears. So we solve those linear equations. We did those. Now we are going to learn nonlinear equations. What are nonlinear equations? That means they are not lines, right? They are those things we have been learning, okay? So your nonlinear equations, like your samples on the page 52, like those. Things like that. And so we need to decide what kind of graphs they are. Like those what? What are they? Like those. So you can solve them, find the solutions, right? Then we need to use the formulas we have learned to decide. So you need to remember all those. Otherwise, you cannot go any further. So we have learned linear things, lines. So what's the formula of lines? So we say standard form is what? Ax plus by equals c, right? X and y, they are just one power of one. So when you graph it, it becomes what? Linear. They didn't bend, right? So then, or we can write it y equals what? Mx plus b in the what? Slope-intercept form, right? So like this, it's y equals mx plus b. That would be a line, right? With the slope-intercept form. Or they write it this way, that means they are written in the standard form, okay? Then for parabolas, what do we have? We have standard form is what? Y equals ax plus square plus bx plus c, right? Y is what? Just one power. X is the second power, right? Or we can write it in a vertex form, ax minus h squared plus k, right? With the vertex is what? H and k, then A decides if it opens up or opens down, right? Depend on the A, positive or negative. What's the formula for the circles? If it's a center in the 0, 0, that would be what? this one, right? If the center is not 0, hk, then it shifts to hk. That would be k squared equals r squared. Is that right? So they have standard forms this way. How about ellipses? Ellipses is what? X squared, we use the center 0, 0 as a center, right? Then for hyperbolas, we just use 0, 0 as a center. So that would be what? Ellipsis is what? X squared over a squared plus y squared over b squared equals what? Which number we use? Always use 1, don't forget. Okay? Then for hyperbolas, it has what? Open this way, left and right, or open and down. Okay? And the formulas are x squared, a squared, minus instead of plus will be y squared, b squared, right? If it's up and down, that would be y squared over b squared minus x squared over a squared, right? Then we use what? Equals 1 to do it. Okay? Then when we have a system of equations, you have to decide, like this one will be what? X squared plus 2. Things like this would be parabola. Then another one would be line. Okay? So we are going to learn where do they meet and find the solutions. So when we say we are going to find the answers for that, it means what? For the system, to solve a system of equations means geometrically we do what? We say where do the graphs meet, right? Of the equation meet. Or at what points do they have in common? Okay, so if North Korea shoot a missile at us, right? Once they initialized, then the trajectory would be fixed. So we can fire the, Patriot missile to intercept. Then the curve would be what? Parabola, both of them, right? Because the gravity. Then we have to decide where do they meet, right? So we want to find the position. Then we want to find the what? Which order the pairs, right? Make all the equations in the system true. So we want to make sure if we find the two curves where they are going to meet, then we have to find the ordered pairs to find the position, right? So when we solve a system of equations, we did what? The linear one in your 152B class, right? Like x plus y equals say 2, 2x minus y say 1. What kind of method do we use? We used one is what? Graphing, right? Another one we use what? Substitution. Then another one we use is elimination or addition method. Okay, then graphing is not too reliable, so usually we just use what? Substitution and elimination. Okay, so let's see some examples how we are going to use this method to solve it. So let's take a look. If we have this example on your page 52, right? Y equals x squared plus 2, y equals negative x plus 4. So when we look at it, we have to decide what kind of shapes they are first. So for the first one, you look at it, x squared plus 2. Y is only what? First degree. So that will be your parabola. So then you decide this parabola is opens up or opens down. So it's up, right? Because leading coefficient is positive. And next one is what? Only one power for the both x and y. So that would be your lines like this. So what do? We graph them first. So for the first one, you use t-table, right? T-table, x and y, y equals x squared plus 2. So for parabola, you have to put a vertex in the middle. So which number you should use? Like vertex form, we didn't move the center, right? So from 0, 0. So you start from 0. You plug in. So you do 1, 2, negative 1, negative 2. So 1 would be 3, 2 would be 6. Right? So what do we have? We have 0, 2, and 1, 3, and 2, and 6. Right? Then another side would be negative 1, 3, negative 2, and 6, right? So that's our parabola. Then we will draw the second one, which is line. So what we do is we can just do the 0, 0, right? X is 0, y is 4, y is 0, x is 4. So it will be what? 0, 4, right? 0, 4, and 4, 0. So we will connect the line, these 2 points, right? Then we find out where do they meet. But we don't know exact position. It looks like that way, but we cannot be for sure. So we have to use the, we have to solve it algebraically so we can find the exact numbers. Okay, so you can either do what? Substitution or elimination. But this one looks like substitution is easier. That's your y, right? Okay, just plug in. So what do we have? We have negative x plus 4 equals x squared plus 2, right? Then write in standard form plus x minus 4. So we have 0 equals x squared plus x minus 2, right? Then we factor it. So what do we have? X plus 2, x minus 1 equals 0, right? Then what do we have? We have x, either x is negative 2 or x is 1. Then what do we try to do? we try to find the ordered pairs, where do they meet, right? So we can plug in to y equals say negative x plus 4. Negative 2, that's 2. So y is what? 6. So this one paired up is what? Negative 2, 6. Right? If 1 we plug in, y is what? Negative 1 is 3. So this one is what? 1 and 3. When you visualize it from the graph, you know how many solutions you have. 2, right? But you cannot tell exactly the position. Then you have to solve it algebraically. Then you find the position will be those, right? That would be your answer. That's how you will solve it, okay? But first, you have to decide what kind of shapes they are according to our formulas, right? So somehow you will have, some of you may have difficulties for solving those equations, because you have to understand all the things you have been learning, okay? What kind of shapes they are before you can even try to resolve it, okay? So let's look at the second one, y equals x squared plus 3. Then we said you can either use elimination method or substitution, right? So if we use a substitution, you are thinking, then you say, okay, y is this. Then you can plug into the y. Then what do you have? X squared plus y is x minus 3. Take square equals 9. If you do that, then you have x squared to the square, x fourth power. It's hard to resolve it. So it may not be so desirable, right? So let's try the elimination. But when you do the elimination, you better write it in standard form. That's the first one. This one will move x squared over. That will be next x squared plus y equals negative 3. Right? So if we add them, then we have y squared plus y equals 6. Then we write it in standard form. That would be this. Then we factor it, right? It would be plus 3 minus 2 equals 0. Right? We try to solve it. But before we solve it, we should graph them first, so we know how many solutions there are possibly be, right? So you look, the first one, x squared plus y squared equals 9, which would be what? A circle. So this one will be circle. The second one, y equals x squared minus 3. So that would be what? Like those, parabola. So then the circle one would be what? Equals 3 squared. So that would be your circle with radius of what? 3. Right? So that would be our circle. Then for the parabola, it opens up, right? So we do our t-table, xy equals x squared minus 3. So we have 0 in the middle. That would be negative 3. 1 would be negative 2. 2 would be 1. Right? You just plug in. Negative 2 and 1 should be symmetrical. So we have what? 0, negative 3 right there. Right? We have 1 1, negative 2, 2, and 1 right here, right? So then we have here negative 1, negative 2, negative 2 is 1. So your curve parabola will look this way. So how many solutions we should expect? 3 of them, right? This one you can tell exact the position, but these 2 are really hard to tell. So we have to use the algebra to resolve it, right? So this one, y equals negative 3, this one, y is 2. But we have to find the ordered pairs. So from y equals negative 3, we can just plug in either one of them. If we plug in y equals x squared minus 3, right? Then what do we have? We have negative 3 equals x squared minus 3. Cancel out, x squared equals 0. So x is what? 0, right? So this ordered pair is what? 0, negative 3. This is one of the solutions. So that's that guy, right? Then how about y is 2? So we plug in here, 2 equals x squared minus 3, right? Then we plus 3, x squared equals 5. Then what's your x? X is, you will only give me square root of 5, which is not right because we say by square root property, we should have what? Plus and minus, right? That both numbers will paired up with 2. So the answer should be what? One is the square root of 5 and 2. Another one is negative square root of 5 and 2. You have to write it separately. So square root of 5 is about 2 point some, right? So it's right here, square root of 5 and 2. Here will be negative square root of 5 and 2. You need to use the radicals to show the answers for the accuracy, because decimal will not do it, will not give you the exact answer, okay? So we solve it algebraically, then you use the graph to first to visualize it and check your answers as well. Right? Manageable, right? Not too bad. So let's look at the next one on your page 53. If you have y is 4x squared plus y squared equals 4 and x plus y equals 3. Right? So let's take a look. What kind of shapes they are? X plus y equals 3, you know, is a line, right? Either that way or it comes down this way, okay? How about the first one? Circles, you have to have x squared plus y squared, but we have 4 in front of it, right? It doesn't look like circle. Then since it's a plus, it's not hyperbolous. So only ellipses left. And let's see, we can make ellipse, right? But for the ellipse, we have to equals to 1. So if we need to do that, then we have to make this one is 1. So what do? You divide everything by 4. Right? Then see what we have. We will have x squared plus y squared over 4 equals 1. So do we have the formula for the ellipses? Right? So we write it this way, y squared over 1 squared, right? Plus y squared over 2 squared equals 1. So we write it in standard form, we can see it. So when we graph it, what do we have? X is 1, right? A is 1, B is 2. So your ellipse will look like this. Okay? Then how about the line? Line, we just use the t-table 0, 0. Then x is 0, y is 3, y is 0, x 3. So 1, 2, 3, 1, 2, 3, right? So your line is this way. So what do you think the answer would be? Do they meet anywhere? No. So it's a no solution. But if you do your exam, you just show this way, that's not good enough because you might make a mistake, right? So from the graphs, we know it's no solution, but you have to solve it algebraically. Otherwise, you only get a half credit, right? Then how should we solve it algebraically? So 4x squared plus y squared equals 4x plus y equals 3. If you use the elimination method, you add them together, you cannot get rid of one variable. That will not help you. Okay? So we will try the elimination method first. Okay? But like this one doesn't work, then we can try substitution. Okay? So you will do what? If my x, then y can be this one. Y is what? Negative x plus 3, right? Then we just plug into y there. So what do we have? 4x squared plus y is negative x plus 3. Take square equals 4, right? Okay, so by substitution, we make two variables, two equations becomes what? One variable, one equation. So we will solve it. That will be, you have to FOIL, 9 plus 6x equals 4, right? Then we have 5x squared plus 6x minus 4 on both sides plus 5 equals 0. Doesn't look like we can factor it. If we cannot factor, how should we do? How can we find out our x? Remember your quadratic formula? X equals what? Negative b plus minus b squared minus 4ac over 2a. Is that right? Then we plug in, that would be negative b is, where is the b? Here, right? Oh, just a second. Let me see. This should be negative. I was looking at. So this one should be what? Negative, right? This one should be negative. So what do we have? B is a negative 6 plus minus b squared. Negative 6 squared minus 4ac. What is your a? 5. What's your c? 5 over 2a. A is 5. So what do we have? 6 plus minus 6 squared 36 minus 100 negative 64 over 10. Right? For the even rule, can we have negative number in it? We can't. Right? So this one doesn't exist. So we don't have our x. Then, so the answer should be what? No solution. That's how you will do it, solve it algebraically. Got the idea? Right? Okay, so in general, we will do the elimination method first because it will be easier. Okay, but if you cannot do it like here, then what do? Then we use substitution method. Right? It's manageable, but somehow some of you will have great difficulty for those for some reason, because you need to have everything. You need to know what kind of shapes are they, and also you need to know everything from your Math 152B class. If you skip your Math 152B class, if you don't remember from high school for your quadratic formula, you won't be able to do this class. Okay? Let's try one more. This one is not on your paper, okay? But it might be on your homework or on the test. Let's cover this as well. So for this problem, first you check what kind of shape is that. For the second one, it's a minus. It just looks like a hyperbola there, right? Then first one, because it's not x squared and y squared, you have something there. So it's not a circle, not a parabola. So we try the ellipse, okay? But for ellipse, you have to have 1 there. So what do? How about divided by 16 for everything? Then see what we have. Then we have x squared over 16 plus this cancel out, become 4, y squared over 4, right? Equals 1. So we made a 1. Then let's write it in standard form. That would be x squared over what? 4 squared plus y squared over 2 squared equals 1. So it is an ellipse. So let's see how it looks like. So x is 2, 3, 4. A is 4. B is 2. So our ellipse will look like here. Right? Then x squared minus y squared is what? A hyperbola. Remember how to draw a hyperbola? We said you need to draw a fundamental rectangle, right? So here is 1 square, 1 square. So you do the fundamental rectangle, right? First, 1, 1. Then you will do what? Your diagonal asymptotes. Then, how do you draw your hyperbola? So hyperbolas, they have 2 types. One is left and right and up and down. So this one, x squared, is positive. So it's what? Left and right. So that's your vertex. So your draw would be what? Close to the asymptote, but don't touch it, right? So your shape would be something like that. But at least give you some visualization, see how many solutions you have, how many places they meet. They meet 2 places. But the exact position, it's almost impossible to tell, right? Then we have to solve it algebraically. So first one, let's just rewrite it. 4y squared equals 16. X squared minus y squared equals 1. Right? And let's see. We can use addition elimination method. Right? Okay, let's just get rid of y. So if I get rid of y, I times this 4, what do I have? 4x squared minus 4y squared equals 1. The top one is this, right? Then what do? We add them together. So what do we have? 5x squared equals, let's see, that's 4. Right? So that would be 20, then divided by 5x squared is 4. Then what's your x? Don't just give me 2. By even rule property, you should have what? Plus and minus 2. Right? Then for x can be what? X can be 2. X can be minus 2. Then let's find the y, right? So when x is 2 or x is minus 2. So we can plug in anywhere. So if I plug in the second one, x squared minus y squared equals 1. X squared is 4. 4 minus y squared equals 1. Minus 4 on both sides. Negative y squared is what? Negative 3. So y squared is 3. Right? Then what's your y? Y would be what? Plus square root. But don't forget your plus and minus. Then how do you write your answer? All right. You need to write the answer clearly. And y can be positive and negative to match with 2. So one of the answers should be 2 square root of 3. Another one should be what? 2 and negative square root of 3. Is that right? 2 and positive and negative. Right? So 3 is 1 point something. So will be what? 2 and square root of 3 is right here. Then this one will be 2 and negative 3. Is that right? How about x is a negative 2? Same thing, you plug in there. Negative 2, right? It's a 4, same thing. 4 minus y squared equals 1. You end up y is plus minus square root of 3. Right? They are the same when you plug in. So what's the order of pairs? So that will be 1 is negative 2 and square root of 3. Another one is negative 2, negative 3, square root of 3. Where are they? One's here. X is negative 2. So this one negative 2 square root of 3. This one is negative 2, negative 2 square root of 3. Right? So you solve, you know you have 4 answers. So you can see exactly the numbers. And some of you will give me this type of answer. You will give me plus minus 2 plus minus square root of 3. If you do that, I will not give you most of the credit because you don't know what you are talking about. You need to write it separately because there is no such thing as ordered pairs. Ordered pairs are individual. You have to write it differently to point to exact positions. Okay? So the most difficult problem you might encounter in this class would be like this. So you know where they are, how do they look like. But first you have to know how to decide what kind of shapes they are to identify how many answers can possibly be B, okay? So that would be the most difficult problem you might encounter for this class. But it is manageable. But you do need to know all this. Also, you need to know how to do the radicals from your 152B class, right? So that will cover our section 11.5.